What if you woke up tomorrow and the sky was on fire? Not with smoke, but with shimmering curtains of green, purple, and red light, visible from every corner of the globe. Beautiful, right? But this isn't a harmless light show. It's the first sign that our planet's single most important defense has just vanished. We live our lives blissfully unaware of an invisible war raging just above our heads. Every second of every day, our sun bombards the solar system with the solar wind, a relentless stream of high-energy charged particles, plasma, and radiation traveling at over 1,000,000 miles per hour. This cosmic hurricane would, if left unchecked, strip mine our planet. It would peel our atmosphere away like the skin from an onion and boil our oceans, leaving a sterilized, barren rock. So why are we all still here, breathing clean air and enjoying sunny days? We have a guardian, a silent, invisible superhero. Deep in the center of the Earth, a massive, spinning core of molten iron and nickel acts like a colossal electric generator. This planetary engine creates a powerful, protective bubble that stretches tens of thousands of miles into space, the magnetosphere. This is our shield. It deflects the solar wind, catches deadly cosmic rays, and funnels those energized particles harmlessly toward the poles, creating the beautiful auroras. It's our planet's force field. It's the only reason life exists on Earth. But what if? What if in a single terrifying instant that engine just stopped? What if the Earth's magnetic field simply disappeared? The scenario isn't a slow weakening. It's not a magnetic pole reversal, which happens every few 100,000 years. In our what if, the shield just vanishes. Blink, and it's gone. The very first thing you'd notice is your compass. It would spin uselessly. GPS systems, which rely on precise timing, would instantly desynchronize as their satellite components are battered by unshielded radiation. But for you, on the ground, the first few minutes might seem normal. Then night would fall, and the sky would erupt. The great aurora would begin. With no magnetic field to guide the solar wind to the poles, these charged particles would slam directly into the entire upper atmosphere. The air itself would glow. It would be a breathtaking global spectacle, but it would be the aurora of the apocalypse, because this beautiful light is the signal that our atmosphere is now under direct, full-scale assault. Within hours, the real chaos begins. The first victims are in orbit. The International Space Station, all 7,000 active satellites, the entire GPS network, our global communications backbone, all of it is now flying naked through a storm of radiation. One by one, their circuits would fry. Solar panels would degrade. Computers would fail. The global network that runs our modern world, our internet, our financial systems, our weather forecasting, our communications, would go dark permanently. Down on the surface, the end of technology is the least of our worries. That beautiful glowing sky is the sound of our atmosphere being sandblasted into space. This process is called atmospheric sputtering. The high-energy particles of the solar wind, no longer deflected by the magnetosphere, slam directly into molecules of oxygen and nitrogen in our upper atmosphere. They hit them with such force that they literally knock them away from Earth, shooting them off into the vacuum of space. It's not an instantaneous explosion. It's a slow, relentless erosion, a death by 1,000 cuts. Scientists estimate that without the magnetic field, our atmosphere would be stripped away over a few thousand years. But the upper atmosphere, which contains our crucial ozone layer, would be the first to go. Ozone, O3, is our fragile, high-altitude sunblock. It's the only thing that stops the most lethal forms of ultraviolet radiation, UVC and high-intensity UVB, from reaching the surface. Without the magnetosphere, the solar wind and cosmic rays would shatter this layer within months, perhaps even weeks. The sun, our source of life, becomes our executioner. The UV radiation hitting the surface would skyrocket. It would be hundreds of times more intense than the worst extreme UV index day you've ever seen. For any human left on the surface, going outside during the day would become impossible. It would be like standing in an open-air microwave. Sunburn wouldn't take minutes, it would take seconds. Severe third-degree burns would cover any exposed skin almost instantly. Your skin would blister, crack, and burn. Worse, this radiation attacks life at a genetic level. It shatters DNA. Cancer rates would explode, not in years, but in weeks. Blindness would become rampant as the intense UV radiation burns our retinas. But the real catastrophe is for the planet's food chain. Plants die first. Photosynthesis, the process that powers nearly all life on Earth, cannot withstand this level of UV bombardment. The radiation shreds chlorophyll. Crops in fields, forests, and jungles would turn brown and wither on a global scale. Algae and phytoplankton in the oceans, which produce over half of our planet's oxygen, would be sterilized in the surface waters. With the plants gone, the herbivores that eat them starve. With the herbivores gone, the carnivores that eat them starve. The entire surface food web collapses, and all the while the air itself is getting thinner. Simultaneously, a new invisible threat is penetrating our homes. Galactic Cosmic Rays. These are not from the sun. They are subatomic shrapnel, the high-speed remnants of distant supernovas, accelerated to near the speed of light. Our magnetic field, along with our atmosphere, currently deflects or absorbs the vast majority of them. Without the shield, they rain down on us. They pass through our roofs, our bodies, and deep into the earth. This hard radiation is a constant 24/7 bombardment. It causes mutations. It causes radiation sickness, nausea, fatigue, hair loss, and failure of the immune system. Every breath you take, every moment you sleep, you are being irradiated. Modern society is over. There is no grid, no internet, no food distribution. But the survivors face a new horrifying reality. The surface of the Earth is now uninhabitable. Humanity must flee. But where? There is only one place left to go: down. Survivors would scramble for the deepest places they can find. Subway tunnels, deep-sea mines, natural cave systems. The new human civilization must be built in total darkness, hiding from the sky. The new human cradle is underground, illuminated by salvaged generators or the pale glow of bioluminescent fungi. We would become a species of troglobites, cave dwellers. Surface operations would be suicide missions. Perhaps clad in lead-lined suits and UV shielding, specialized teams would make desperate runs to the poisoned surface to scavenge for technology, canned goods, or preserved seeds. But the vast majority of humanity would never see the sun again. Life would revolve around the three new essentials: shielding, air, and food. Shielding, miles of rock and soil, would provide the only reliable protection from the constant cosmic ray bombardment. Air, with the atmosphere slowly thinning and the surface plants dead, oxygen becomes the most precious resource. Underground hydroponic farms powered by geothermal or salvaged nuclear energy would be our only source of breathable air and food. Food. These subterranean farms would grow mutated, UV-resistant fungi and perhaps specially bred insects. Livestock on the surface, a distant memory, but humanity is not the only thing fighting to survive. Life adapts. The immediate extinction event would be catastrophic. Most large surface animals, mammals, birds, reptiles, would be wiped out by starvation, radiation, and cancer. But in the deep oceans, life has a chance. Water is an excellent radiation shield. While the surface, the photic zone, becomes a sterile soup, life in the deep ocean trenches and around geothermal vents would be almost completely unaware of the apocalypse above. Crabs, tube worms, and bizarre fish clustered around these black smokers would continue to thrive on chemical energy, chemosynthesis, not sunlight. These deep-sea oases would become the new cradles of evolution. On the surface, the only survivors would be the extremophiles, bacteria like Deinococcus radiodurans, a superbug that can withstand 1,000 times the radiation dose that would kill a human, would thrive. It can literally reassemble its own shattered DNA. These radiation-resistant microbes would begin to slowly, over millennia, reclaim the surface. What about evolution? If life holds on, what does it become? This is where the scenario gets truly strange. Life would be forged in an environment of high mutation. Radiation is a powerful engine of genetic change. On the surface, any plant life that eventually re-evolves would need defenses. We might see plants with thick, waxy, reflective cuticles to bounce radiation, or entirely new, dark pigments to absorb and dissipate it. Animals that dare to return to the surface would look alien. They might evolve thick, scaly, or armor-plated hides, natural radiation shielding. Perhaps new forms of life would evolve to use the radiation, but the most profound change would be to us. The underground human civilization would be a genetic bottleneck. With high background radiation still filtering down, mutation rates would be high. Cancers and birth defects would be common, but evolution is ruthless. Any small genetic trait that offered even a 1% better resistance to radiation sickness would be powerfully selected for. We might see humans evolve tougher skin or incredibly aggressive DNA repair mechanisms in our cells, far beyond what we have today. Over thousands of years, we might split. The deep humans would adapt to the dark, perhaps losing their skin pigmentation and developing enhanced hearing or touch, like other cave-dwelling creatures. And if any surface dwellers survived, they might become something else entirely, a hardened, radiation-resistant subspecies forever changed by the hostile sun. But this new, brutal evolution would be racing against a clock, because while life is fighting to adapt, the planet itself is dying. The atmospheric stripping, which began in the first hours, has never stopped. Millimeter by millimeter, the sky is being scraped away. As the air pressure drops, the oceans begin to boil. This isn't boiling from heat, it's boiling from low pressure. Water's boiling point depends on the air pressure pushing down on it. At the top of Mount Everest, water boils at just 100 °C. As our atmosphere thins to nothing, the pressure drops so low that the oceans will boil away at room temperature, or even colder. A vast, cold fog would envelop the planet as the seas evaporate into the thinning atmosphere, only to be immediately blasted away into space by the solar wind. In a few thousand years, the Earth is unrecognizable. The oceans are gone. The air is gone. The planet is a silent desert world, scoured clean by unfiltered radiation. It is a new Mars. The surface is sterile. The only life that could possibly remain would be those extremophile bacteria, buried deep in the rock, perhaps in pockets of briny water, dormant and waiting. The human experiment, along with the entire complex 3.5 billion-year history of life on Earth, would be over, wiped out by the loss of one invisible planetary shield. It's a terrifying scenario, but could it actually happen? Our planet's core has been spinning and generating its field for over 4 billion years. It's not expected to stop anytime soon. It does, however, weaken and fluctuate. It does flip its poles. But a complete and sudden shutdown? As far as we know, that's not how planetary physics works. The Earth's magnetic field is a fundamental part of its existence, as core to its identity as its oceans or its atmosphere. It's a startling reminder. We are fragile. We exist in a cosmic balancing act, protected from a violent universe by an invisible force we can't see, touch, or hear. We are, and have always been, children of the magnetosphere,